A wheel is rolling on a plane surface. The speed of a particle on the highest point of the rim is 8 meter per second. The speed of the particle on the rim of the wheel at the same level as the center of wheel will be option A 4 meter per second, option B 8 root 2 meter per second, option C 8 meter per second, option D 4 root 2 meter per second. This MCQ came in 4th April shift to 2025 JEE mains examination. Students, let me label this lowest point as A, highest point as B, and point midway as a C. Alright, or we can do one thing, let me label this center as C, fine, and ये पॉइंट को लेबल कर लेते हैं फिर डी. सो सेंटर इज द सी एंड मिड वे मतलब सेंटर के लेवल में जो राइट की तरफ आपको पॉइंट दिख रहा है दैट पॉइंट इज डी. इतना समझेगा स्टूडेंट्स को. सो कैन आई से velocity at A will be 0 because velocity of center of mass, okay, is towards right while r omega is towards left. So net velocity will be, sir, net velocity will be v minus r omega at point A. All of you agree with this? But for pure rolling motion as per the data, value of v and value of r omega will be same only. So v minus v will give you 0, right? So velocity at point A, that is lowest point, is 0. Getting this? Now students, what about highest point B? At highest point B, the velocity will be vb, which is equals to velocity of center of mass v plus r omega. But as per our recent discussion, for pure rolling motion, v and r omega are same only. So v plus v will give you 2v basically. Now as per the data in second line उन्होंने आपको एक value दिया है 8, right? The speed of the particle on the highest point of the rim is 8 meter per second. So 2v is equals to 8 meter per second. So can I say this applies, the value of v will be 4 meter per second. 2v is equals to 8, so v can give you 4, obvious. So the value of v is equals to 4 meter per second. Is this the requirement? No. The speed of the particle on the rim of the wheel at the same level as the center of wheel, that means उनका demand है velocity at d. First of all, can I say students, velocity for center of mass is vcm, जिसको हम यहाँ v consider कर रहे हैं, which is again towards right. Alright, where is r omega right now? At point d, it will be along negative y axis. तो आप मुझे बता सकते हैं नेट वेलोसिटी कैसे मिलेगा बेटा आपको भी? यस, व्हाट इज द नेट वेलोसिटी ऑफ दीज टू v एंड r ओमेगा? कम ऑन, यूजिंग बेसिक नॉलेज ऑफ वेक्टर आप उसको v नेट लिखोगे एंड v नेट का मैग्नीट्यूड क्या होगा स्टूडेंट्स बोलो? v नेट विल बी अंडर रूट ऑफ v स्क्वायर प्लस r ओमेगा द होल स्क्वायर. But we know the story now, pure rolling motion, right? So v and r omega are numerically same only. So this will become root of v square plus v square, that is 2v square. So total will be root 2 multiplied by v. And recently हमको v का value मिला, कितना मिला बेटा? It is 4 meter per second. So root 2 multiplied by 4. So overall your answer will be 4 root 2 meter per second. So this is the net velocity at which point, sir? At point D. So आप लेबल कर लो उसको VD. yes, net velocity at point D magnitude आपको मिल गया 4 root 2 meter per second, right? So this is going to match with option D ना बेटा, चेक करो. Option D, yes, option D, 4 root 2 meter per second. Simple question. Yes, complete this. A force of 49 Newton acts tangentially at the highest point of a sphere solid of mass 20 kg kept on a rough horizontal plane. If the sphere rolls without slipping, then the acceleration of the center of the sphere is how much? Option A 2.5 meter per second square. Option B 0.35 meter per second square. Option C 0.25 meter per second square. Option D 3.5 meter per second square. This MCQ came in 3rd April shift 1 2025 JEE mains examination. Alright, students, here I can start with the basic formula of tau torque in our rotational motion. Tau is equals to I alpha. Yes, you remember this? Tau I have used for torque, that is equals to I alpha. I is moment of inertia while alpha is angular acceleration. Alright, now यहाँ पे it is clearly specified that the sphere rolls without slipping. That means मैं tau को लिख सकता हूँ students f multiplied by r perpendicular. Students, what is the distance between these 2 points, lowest point and highest point? This is nothing but, आपने चेक किया ना students, lowest point है वो fixed है, at highest point you are applying the force, right? So basically आप जब tau लिखते हो आप ऐसा लिखते हो ना, f multiplied by r perpendicular. And how much is r perpendicular, tell me? That is nothing but diameter of this solid sphere, which is definitely 2 times the radius. So basic formula for tau is I alpha, वो मैंने start किया. Then instead of tau I am using f into r perpendicular. And sir, r perpendicular is not r. Check the diagram, okay? That's 2r. That is equals to students moment of inertia I as it is multiplied by alpha. Okay, we can do one thing students. हम यहाँ से अल्फा एलिमिनेट करने को ट्राई कर सकते हैं. डू यू नो दैट ए विल बी इक्वल्स टू आर अल्फा? यस स्टूडेंट्स, क्या कहते हो आप इसे? दिस इज द रिलेशन बिटवीन लीनियर एंड एंगुलर एक्सीलरेशन. ए इज इक्वल टू आर अल्फा. सो इंस्टेड ऑफ अल्फा कैन आई यूज स्टूडेंट्स ए बाय आर? कैन आई डू दैट? इट इज ए बाय आर. ऑलराइट, सो आई थिंक आप थोड़ा इसको सिंप्लीफाई कर सकते हैं बिफोर सब्स्टिट्यूटिंग द वैल्यूज एंड ऑल. आपको क्या ढूंढना है स्टूडेंट्स? लेट मी रिमाइंड यू, आपको ढूंढना है acceleration, right? Acceleration of the center of the sphere is. So we have to find out A. So formula for A will look like this students. 2f r into r will become r square divided by I. Getting this students? So formula for A आपको मिल चुका. That's 2fr square divided by I. Yes sir. So let me first substitute this formula of moment of inertia, 2fr square. Students, what is the formula for moment of inertia for solid sphere? Mind you, it is about tangential axis, central axis nahi. It will be 7 by 5 mr square. Yes sir. It is rotating about its tangent. Yes. So it is 7 by 5 mr square. I am using this as the formula for moment of inertia of the solid sphere, right? I think radius small r है ना, ठीक है, तो मुझे यहाँ small r लिखना चाहिए. No problem sir, लिख देते हैं. So this is small r. Alright. So as you can observe here, r square will cancel out, right? Mass will remain, force will remain. So this will look like in the next step 10 by 7 into f by m. Alright students, so acceleration A will look like 10 into, sir, what is the value of force given to you? That's 49 Newton. 49 divided by 7 into mass. Mass का value है students, second line देखो, 20 kilogram. Alright, so some simple cancellation we can do now. So यहाँ से आप एक ज़ीरो कैंसिल कर लीजिए पहले तो. Okay, then 7 into 7 can give you 49. So therefore A will look like students 7 by 2. That is obviously 3.58 is. So unit will be meter per square second. So the required value of acceleration is 3.5 meter per square second. So this is going to match with students 3.5, right? Option D. A cord of negligible mass is wound around the rim of a wheel supported by spokes with negligible mass. The mass of wheel is 10 kilogram and radius is 10 centimeter and it can freely rotate without any friction. Initially the wheel is at rest. If a steady pull of 20 Newton is applied on the cord, the angular velocity of the wheel after the cord is unwound by 1 meter would be option A 0 radian per second, option B 10 radian per second, option C 30 radian per second, Option D, 20 radian per second. This MCQ came in 2nd April, Shift 1, 2025 examination. Students, first of all, यहाँ clearly बताया जा रहा है the mass of wheel is 10 kilogram, right? And radius is 10 centimeter. So for the wheel, mass M is 10 kilogram and its radius R is 10 centimeter, that is 10 raised to minus 1 meter. F value given to you, diagram में भी दिख रहा होगा आपको, it's 20 Newton. Wheel was initially at rest, right? So omega naught, that is initial angular velocity, is 0. Alright, ये last line देखा आप लोगों ने. After the cord is unwound by 1 meter, we can use this data to calculate theta, angular displacement theta in some time. But उसके पहले एक और noticeable point है students. Cord of negligible mass is wound around the rim of a wheel supported by spokes with negligible mass. So mass of spokes is given negligible. So definitely ये जो wheel है उसे मैं एक ring consider कर सकता हूँ. Yes, it's not a disc, it's a ring. ये समझा आपको? Alright. So let me start with the initial calculation related to moment of inertia. Guys, for the ring, moment of inertia I will be mr square. Yes. So this will be 10 kilogram into 10 raised to minus 1 square, that is 10 raised to minus 2. So total I will get 10 to the power minus 1 kilogram meter square. This is the moment of inertia I. Alright. Next, can I find out torque tau now students? देखिए टॉर्क के मेरे पास वैसे तो दो फॉर्मूले होते हैं, आर वेक्टर क्रॉस एफ वेक्टर. मैग्नीट्यूड वाइज क्या बोलेंगे आप? टाउ इज आर एफ मल्टीप्लाइड बाई साइन थीटा, राइट? So it's RF multiplied by sine theta. Now for sure students, the angle between applied force F and R vector is 90 degree. Correct है? समझ में आ रही बात? So theta will be by default 90 RF sin theta. And same torque को पता है ना हम लोग I alpha लिखते हैं बेटा. Yes. So what you can do now? In fact अगर आपको ये R को extend करना है आप कर सकते हैं. R vector is this, right? And this is your F vector. बट जैसा मैंने आपको बताया जो एंगल है वो तो बाय डिफ़ॉल्ट 90 है ही, जिसमें आपको और इसको एक्स्ट्रा बता रहा था, राइट? सो आर विल बी, इन फैक्ट स्टूडेंट्स, टाउ विल बी आर एफ साइन 90, दैट इज इक्वल्स टू आई अल्फा. सो दैट मीन्स रेडियस इज 10 raised to minus 1 meter, अप्लाइड फोर्स इज 20 न्यूटन, साइन 91 है, दैट इज आई, मोमेंट ऑफ इनर्शिया इज 10 raised to minus 1 मल्टीप्लाइड बाय अल्फा इज अननोन राइट नाउ. सो अल्फा विल बी स्टूडेंट्स 20. गेटिंग दिस? The value of alpha is 20 and yes it's alpha, so unit will be radian per second square. Obvious, alpha मिल गया students को 20 radian per second square. So using the knowledge of I you found tau and then tau के दो फॉर्मूले equate करके we found alpha, angular acceleration alpha 20 radian per second square. Now मैं क्या सोच रहा था students, that we can use third kinematical equation for rotational motion. But there is one problem in that, till now आपको थीटा नहीं पता है. So for that I can use your formula related to plane angle, right? So theta, plane angle theta को हम कह सकते हैं students length of arc, okay, it's length of arc divided by radius. Yes, you all know this. So length of arc is given to you 1 meter. Check this, मैंने कहा था इसको use करेंगे हम in some time. 1 meter divided by the radius is 10 raised to minus 1 meter, right? So this will be 10 and the good part is ये formula से directly we will get theta in SI unit which is nothing but radian. So theta will be 10 radian students. This is not the final answer. Let me remind you, आपको ढूंढना है final omega. Yes, the angular velocity of the wheel after the cord is unwound by 1 meter would be, तो final omega is omega only. Omega is question mark. So let's use third kinematical equation now for rotational motion. That looks like this. Omega square is equal to omega naught square plus 2 alpha theta. That means omega square will be, omega naught is 0, right? So 0 square plus 2 alpha sir 20, ये रहा alpha 20 radian per second square into theta is your 10 radian. So that means omega square will be, students, 400. Yes, so taking square root on both sides, I will be getting omega as 20 radian per second. So the required angular velocity, that is final angular velocity, omega is 20 radian per second, and that's why this is going to match with option D. Complete these, students. 20 radian per second, this is your answer. Okay. Next question now. A circular ring and a solid sphere having same radius roll down on an inclined plane from rest without slipping. The ratio of their velocities when reached at the bottom of the plane is under root of x by phi, where value of x is question mark. This question came in 4th April shift 1 2025 examination. Students, I think this is a formula based question. जल्दी से सॉल्व हो जाएगा आप लोगों से. So this is related to rolling motion, right, on an inclined plane. Now formula for velocity in this situation will be v is equals to under root of 2gh divided by 1 plus k square by r square, correct? What is k? Let me remind you, k is radius of gyration, right? Now मैंने देखा there are two different structures out there. One is circular ring and another is a solid sphere. But can I say 2gh, ये तीनों terms तो same है for these two structures, alright? रोल डाउन ऑन एन इंक्लाइंड प्लेन, सेम इंक्लाइंड प्लेन है दोनों के लिए, तो h का वैल्यू कॉमन ही हो गया, राइट? सो जस्ट आप एक काम कर लो, आप मुझे बता दो व्हाट इज k स्क्वायर बाय r स्क्वायर फॉर अ रिंग, एंड देन सेम वे व्हाट इज k स्क्वायर बाय r स्क्वायर फॉर अ सॉलिड स्फीयर. फॉर अ रिंग k स्क्वायर बाय r स्क्वायर इज 1, एंड स्टूडेंट्स फॉर अ सॉलिड स्फीयर, राइट, सेम k स्क्वायर बाय r स्क्वायर विल बी 2 by 5. So this is for a 2 by 5, right? This is for a solid sphere. This simply means velocity ka ratio will look like this, v divided by v, right? It's ring divided by solid sphere ka velocity. So this will be root of, students, 1 plus k square by r square for the solid sphere, which is 2 by 5, over 1 plus k square by r square for a ring is nothing but 1. Just as you can observe, 2gh everything is constant, so v will be inversely proportional to square root of 1 plus k square by r square. Obvious? That is the reason LHS में मैंने velocity किसका ढूंढा ratio? Ring divided by solid sphere. But on RHS I took solid sphere divided by ring because relation is inverse. Obvious? So next step थोड़ा maths करना है आपको. This will look like root of, students, 7 by 5 divided by 2. Alright. Now as per the data, the same value is, students, root x by 5. Can you find this? Root of x by 5. Just compare this, you will get to know that the value of x is 7 by 2, because 5 तो common दिख रहा है मुझे दोनों के denominator में. So x is the value of x is 7 by 2, that is 3.5. So the required value of x is 3.5, right? But as we know, this is integer type question, so I can round off this to 4. So you can go with this value, x is equals to 4. So this is your answer. Integer will be 4. So the value of x here will be 4. Alright. A thin solid disc of 1 kilogram is rotating along its diameter axis at the speed of 1800 rpm. By applying an external torque of 25 pi Newton meter for 40 seconds, the speed increases to 2100 rpm. The diameter of the disc is dash meter. This question came in 8th April shift 2 2025 examination. Alright. So as per the data, students, it's a solid disc. whose mass is 1 kilogram. Initial frequency, let me denote this by Fi, right, is 1800 rpm. Then final frequency, let me consider that as Ff. Final frequency Ff is 2100 rpm. Right. Now the applied torque tau is 25 pi Newton meter. For how much time? That's 40 seconds. So small t time is 40 seconds, right students? Then the diameter of the disc is the requirement. D is question mark students. Diameter of the disc, right? ये आपको यहाँ पे ढूंढने बताया जा रहा है, right? So I think we can start with the discussion of kinematical equation, students. Yes, I think first kinematical equation for rotational motion will be best over here. Omega final is equals to omega initial plus alpha times t. Yes sir, omega final is omega initial plus alpha times t. इससे स्टूडेंट्स आपको अल्फा मिल जाएगा. देन यूजिंग द फॉर्मूला फॉर टॉर्क टाव इज इक्वल टू आई अल्फा, आपको आई मोमेंट ऑफ इनर्शिया मिल जाएगा. देन यूजिंग दैट वैल्यू ऑफ मोमेंट ऑफ इनर्शिया वी कैन फाइंड आउट द रेडियस एंड देन डबल करके वी विल गेट द डायमीटर. सो दिस इज द सीक्वेंस दैट वी आर गोइंग टू फॉलो. फर्स्ट ऑफ ऑल आई एम यूजिंग फर्स्ट काइनेमेटिकल इक्वेशन फॉर रोटेशनल मोशन जो मैंने आपको बताया रिसेंटली. ओमेगा फाइनल इज ओमेगा इनिशियल plus alpha times t. That means students omega final minus omega initial divided by time is alpha. Obvious. So alpha will be, let me take 2 pi common. So alpha will be 2 pi into final frequency minus initial frequency the whole over time. Alright. So that means angular acceleration alpha will be 2 pi. So what is the final frequency? That's 2100 rpm. So I just have to divide by 60 so that मुझे यूनिट rps दिख जाए. rps revolutions per second. So 2100 divided by 60 can give me 35, right? So 35 rps. What about the initial frequency? 1800 divided by 60, that will give you 30 rps. Obvious. So 2 pi I took common. Final frequency students 35 minus initial frequency is 30. Let me divide this by time. The given value of time is 40 seconds. Alright. So this will be students 2 pi multiplied by 5 divided by 40. So 10 into 4 is 40. So this will give you pi by 4 students. So alpha is pi by 4 radian per second square. Getting this students? Angular acceleration alpha is pi by 4 radian per second square. Okay, getting this my students? Yes, I think हमारा डील हुआ था that हम अल्फा कैलकुलेट करके टॉर्क जो गिवन है उसका यूज़ करके टाव इज इक्वल टू आई अल्फा में सब्सटीट्यूट कर लेंगे. सो वी कैन गेट मोमेंट ऑफ इनर्शिया आई, राइट? सो टेल मी बेसिक फॉर्मूला फॉर टॉर्क टाव इज इक्वल्स टू आई अल्फा. So moment of inertia I will look like tau divided by alpha. Torque का value given to you is 25 pi Newton meter divided by alpha, which is pi by 4 radian per second square. Pi we can cancel out. हमें मिलेगा students 25 into 4, that is 100, correct? So moment of inertia I will be 100. What is the unit? Come on, kg meter square. Getting this students? Moment of inertia 100 kg meter square. What next now? Diameter of the disc is what we have to find out. तो radius पता कर लेंगे using this value of moment of inertia. Obvious. But क्या आपने ये ध्यान से read किया first and second line students? A thin solid disc of 1 kilogram is rotating along its diameter axis. So for the solid disc, right? Moment of inertia about the diameter axis I can use 1 by 4 mr square. Yes students, getting this? Now tell me, id moment of inertia जो आपको मिला वो है 100, this above value 100. This is equals to 1 by 4 into the given mass is this 1 kilogram students into square of radius, right? So this will give you students 400 is equals to r square. Just taking square root of both sides मुझे radius मिल जाएगा 20 meter. But let me remind you, they are demanding diameter, right? So one more step now. So diameter is equals to 2 times the radius, 2 times 20, that will give you 40 meters, students. So the required value of diameter is 40 meter. So ये जो blank उन्होंने आपको दिया है, right, the diameter of the disc is dash meter, वो dash में जो integer आएगा that will be 40. Complete this, students. 40 meter, this is the required diameter का answer. 40 meter, 40. Complete this. A solid sphere with uniform density and radius r is rotating initially with constant angular velocity omega 1 about its diameter. After some time during the rotation, it starts losing mass at a uniform rate with no change in its shape. The angular velocity of the sphere when its radius becomes r by 2 is x times omega 1. The value of x is dash. This question came in 4th April, shift to 2025 examination. So first of all students, आपको यहाँ पर रेडियस का डेटा गिवन है r by 2, उससे आपको मास का डेटा निकालने आना चाहिए, राइट. So let me go in a stepwise manner. So it's a solid sphere where density is uniform, alright, its radius is r, alright. Now what happens is its initial angular velocity is omega 1, yes sir, about its diameter. ठीक है students. अब क्या हो रहा है students, it is losing mass and the shape is not getting affected. मतलब both the times shape जो है वो solid sphere है, so moment of inertia आपको पता है same रहेगा 2/5 mr square. What next? Its radius is becoming r by 2, जो मैं आपको एक मिनट पहले बता रहा था, its radius is becoming r by 2. Now can I say students, for a solid sphere rho will remain constant? Yes, rho is your students पता है ना आपको, volume density, this will remain constant. Now basic formula for volume density rho is mass per unit volume, alright. So can I say radius is becoming r by 2, r is becoming r by 2 basically. So volume of the sphere will be 4/3 pi r cube. So when radius becomes half, can I say volume becomes v by 8, and because of that mass will become m by 8 times. ये मैं कह रहा था students आपसे. So radius is becoming half, because of that volume is becoming 1/8 times, and because of that mass is becoming 1/8 times. Getting the students? Because density should remain constant, so mass per unit volume should remain constant. वॉल्यूम अगर 1/8 टाइम्स होगा तो मास भी तो 1/8 टाइम्स होगा. क्लियर है? नाउ टेल मी, यहाँ पर कैन आई यूज लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम? यस, लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम स्टूडेंट्स. व्हाट इज टाउ एक्सटर्नल ओवर हियर? कम ऑन, 0 ओनली. That is the reason with confidence हम use कर सकते हैं, right? Law of conservation of angular momentum, alright? In that situation मैं कह सकता हूँ students, angular momentum initial value is equals to angular momentum final value, alright? Now for angular momentum initial I will use I1 omega 1 and final angular momentum LF will be I2 omega 2. Getting this students? Now, what is moment of inertia I1 students? Initial one, tell me. 2/5 mr square into omega 1 as it is. Now that is equal to moment of inertia I2, final moment of inertia I2. So 2/5, yes students. What about the mass? Mass is becoming 1/8 times. Check this, m/8 लेना पड़ेगा फिर आपको. Final mass is m/8. 2/5 into mass into square of radius. How much is the radius? The new radius now, it's half as compared to the original one. So 2/5 into mass into radius ka square, that is r by 2 the whole square. Getting the students? Into omega 2 as it is. Alright. So we can do some cancellation now here. 2/5 will cancel out. M will cancel out, right? Radius square. Simplify करके cancel करते हैं फिर. So r square into omega 1 students will give you 1/8 into r square divided by 4 and as per the data आपने देखा होगा that omega 2 का जो value है, right, omega 2 is x times omega 1 students, yes. So omega 2 I can replace by x times omega 1, getting this? So now r square will cancel out, right? Omega 1 will also cancel out. So you will be getting, students, 1 is equals to 1 upon 32 into x, right? So just doing this cross multiplication now, we will be getting x is equals to 32. So the blank is containing x, right? X is how much? So the required value of x is 32. So I can just substitute now. The value of x is 32. This is your answer, okay?